Assalamualaikum. For our project, we decide to do the earthquake detector. This is our group member. First, Priya Tashini, anak perempuan Ramalingam. Second, Nurul Nabila binti Muhammad Rozi. Third, Nur Faha Atik binti Jaafar. Fourth, Muhammad Haris Izri bin Ahmad Khairi. And that's me, Muhammad Dini Hakim bin Azhar. Today I want to talk about introduction. What is earthquake detector? The earthquake detector can detect when the earthquake is coming to the certain place. The detector will detect incoming voltage as the source of earthquake warning. With certain voltage, the alarm will ring and detect the earthquake. For example, when we set the voltage below 0 volt, nothing will happen as it means that no earthquake is coming. But when we set the incoming voltage at 1 volt and above, the alarm will turn on and the LED will light up so that it detects that the earthquake will coming. For this project, we use Proteus 8 for design the circuit and check the connection between components by using PCB layout.
Components and the functions. The first component is 555 timer. The 555 timer is a commonly used IC designed to produce a variety of output waveform with the addition of an external RC network. The timer has 8 type of pin, which is pin 1 is ground, pin 2 is trigger, pin 3 is output, pin 4 is reset, pin 5 is control voltage, pin 6 is threshold, pin 7 is discharge, and pin 8 is supply plus VCC. Then second component is battery. A battery simulator is a special kind of power supply that can output positive voltage while can sink and source current. This type of power supply is called a two-quadrant power supply. The third component is BC548. Is a transistor. It's used for amplifying and switching purpose in electrical circuit. Like every other NPN transistor, it consists of 3 pins, which is the collector, base and emitter. The fourth component is LED ray. In the simplest term, a light emitting diode is a semiconductor device that emits light when an electric current is passed through it. Light is produced when the particles that carry the current, known as electrons and holes, combine together within the semiconductor materials. The fifth component is LM741. The 741 operational amplifier is a monolithic integrated circuit comprising of a general purpose operational amplifier. It can be used as a comparator in order to determine the level of applied input voltage, whether smaller or larger input voltage are applied at its input terminal. And the next is POT, pot HG. A potentiometer is a type of resistor phasing variable and adjustable resistance controlled via a sliding or rotating contact. In order to regulate resistance, the potentiometer acts as a voltage divider, lowering or increasing the voltage output by controlling the resistance value. And the next is resistor. A resistor is a passive two-terminal electrical component that implements electrical resistance as a circuit element. In electronic circuit, resistors are used to reduce current flow, adjust signal level to divide voltage, bias active elements, and terminate transmission line among other uses. The 8 components is capacitor, electrolyte. An electronic capacitor is a polarized capacitor which anode or positive plate is made of a metal that form an insulting oxide layer through anodization. Next is speaker. A loudspeaker is an electroacoustic transducer, a device which converts an electrical audio signal into a corresponding sound. The most widely used type of speaker is the dynamic speaker. The sound source must be amplified or strengthened with an audio power amplifier before the signal is sent to the speaker. And the last one is capacitor. A capacitor is an electrical component that draw energy from a battery and store the energy.
We will present about function of circuit. As we mentioned above, this project initiative is to create a detector system, which is by using timer 555 for detecting earthquake vibrations in the near future, so that whenever vibration occur, the timer 555 sends the vibrations and convert them to the LED and the speaker, which is output. In this project, we are using the audio generator, which is piezo element, to calibrate the timer 555 by taking the samples of WAV audio. Then the output will detect the vibrations or wave when the voltage set in 1 volt above. This is working principle of our project. Okay. First of all, as we know, when the earthquake happens, it will release a vibration and wave. Then the vibration and wave will go into the LM741 to determine the level input voltage, then flow to the BC548 for amplifying and switching in electrical, then change two waveforms at timer 555. Then it will detect to the output, which is LED and speaker.
Okay, for the circuit schematic diagram, so how to do it? First, we must have a 555 timer IC, a 12 volt battery, BC548, low power non bipolar transistor, a non electrolytic capacitor, electrolytic capacitor, an LED, LM741 operational amplifier, port HG potentiometer, a resistor, a speaker, and audio generator. Okay, so firstly, we are going to place the audio. Okay, then we are going to change the generator name to piezo element. For the amplitude, we are going to set it to 0. So for this, we must have a .wav file as the audio file for our project. So we're going to use this. Okay. Next, we're going to assemble the circuit. So we're going to place the potentiometer here. So this circuit function as firstly the piezo element. We must need a WAV file as an audio file. So this piezo element detects the incoming voltages as the source of earthquake trigger. So if we set it to 0 volt, it means that there is no earthquake coming. So if it is 1 volt and above, there is earthquake. Then it will go to the potentiometer, which is to set the sensitivity of this piezo element. So usually we can set it to 50% of or 51%. Okay, that's the voltage will be coming into the LM741 IC, which is to amplify the signal from piezo element, that which is triggers the BC548, the transistor, which is when BC548 triggers, it will trigger the state of the 555 IC timer circuit, which is from high to low or low to high, and which will trigger the alarm and the LED indicator to show, to give the warning about the earthquake incoming. That's all for this schematic diagram circuit.
So my part is to perform PCB layout. Firstly, we must know size board. Okay, for this circuit, we set 8 mm times 8 mm. So before we start, we set all the components. All the components must have PCB symbol. So all the components have the PCB symbol. After that, we select the dimension. And then we select 2D graphic board and select board edge. Draw the box according to the measurement. Then we place all the components inside the board edge. After finish, place all the component on PCB board. We can begin routing by select auto router and begin routing. Okay, so finish. Okay, for more thickness of the layout, we select design as 0 and select default. So we choose T40 and click OK. Next, we want to view the PCB layout at view plot. So before that, we must perform supervise. So choose play output and generate supervise. So click yes. Okay. Top copper, button copper, top switch, button switch, top resist, button resist, third click. Okay, untick this. Click OK. After generate Java file, choose file, open the vplot and choose file. Okay. Select all of this, click open. So we finished for vplot.
Assalamualaikum, and my name is Muhammad Dini Hakim bin Azhar, and today I want to talk about introduction. What is earthquake detector? The earthquake detector can detect when the earthquake is coming to the certain place. The detector will detect incoming voltage as the source of earthquake warning. With certain voltage, the alarm will ring and detect the earthquake. For example, when we set the voltage below 0 volt, nothing will happen as it means that no earthquake is coming. But when we set the incoming voltage at 1 volt and above, the alarm will turn on and the LED will light up so that it detect that the earthquake will coming. For this project, we use Proteus 8 for design the circuit and check the connection between components by using PCB layout.